Okay, so we're going to prove the side-angle side similarity theorem, which states that if the corresponding side lengths of two sides of one triangle are proportional to the lengths of two corresponding sides of another triangle, and the included angles are congruent, then the triangles are similar. So in essence, we want to prove that if RS over XY is equal to TS over ZY, and they're equal to the same proportion lambda, and angle S is congruent to angle Y, then triangle RST is similar to triangle XYZ. So let's go ahead and do this proof. So proof. So we have that RS over XY is equal to lambda, and this implies that RS is equal to lambda times XY. So this basically, in essence, tells us that RS is equal to some proportion times XY, and in the picture you can see that XY is just bigger than RS, right? So it's a proportion bigger than RS. All right. So what we can do in this case is this implies that there exists a J on XY where JY is congruent to RS. So let me go ahead and do that here. So we'll have this line here, right? And we have that J right here, so that JY is congruent to RS. And then the reason why I drew this line here is, of course, we can do the parallel postulate that goes from J to an element here, K. So by the parallel postulate, we want to draw JK that is parallel to XZ. Okay? So, of course, this implies by the corresponding angle postulate that this angle here, angle YJK, is congruent to angle YXZ. So this implies that angle YJK is congruent to angle YXZ. And then, of course, we have S is congruent to Y here, right? So hopefully you can see that triangle JYK is going to be similar to triangle XYZ because we have at least two corresponding angles that are congruent. So we have angle YJK is congruent to angle YXZ, and angle Y is congruent to itself, right? Angle Y is congruent to angle Y. So these two things together imply by angle that triangle JYK is similar to triangle XYZ. Okay? So if these two triangles are similar, this means that JY over XY, JY over XY is equal to KY over ZY. Right? So remember, since JY is equal to RS, right? We got that from here. This implies that JY over XY is equal to RS over XY. But we also know RS over XY by assumption is equal to TS over ZY. And of course, JY over XY is equal to KY over ZY. All right, so hopefully you can see this implies that TS over ZY is equal to ky over zy. And of course, this implies that ts is equal to ky, because we can multiply both sides of this equation by zy. So what we have is we have rs is congruent to jy. Remember, we had these over here. So we also have that here ts is congruent to ky. So we have enough to show that triangle RST is congruent to triangle JYK by side angle side congruency theorem. So I know that RS is congruent to JY. I have angle S is congruent to angle Y. And I have ST is congruent to YK. So these three things together imply, by side angle side congruency theorem, that triangle RST is congruent to triangle JYK. Now, remember, we proved that triangle JYK was similar to triangle XYZ, right? XYZ. And we have that triangle JYK is congruent to triangle RST. So if XYZ is similar to JYK and JYK is the same as RST, this implies that triangle RST must be similar to triangle XYZ. And that's exactly what we wanted to prove. And that is the proof of the side angle side similarity theorem.